I multiplied and reduced in the same step. Hopefully I didn't lose you.
Where do you get the?
Okay?
Oh, screw.
So far so good? Pretty easy? Let's throw a change
That
up.
is screw.
Try this one. Seems like the same thing. Give it a try. What do you think U is gonna be? X plus 3? Alright, so we're replacing that. We need to replace this guy. So find the derivative. du equals dx? Uh-oh. What's the problem here?
The X doesn't go.
The x doesn't go away.
But it turns into
Right?
U minus 3.
I didn't get rid of the x by finding du. Right? So what do I have to do to get rid of that x? How can I replace it?
Oh, that. In terms of
I need to do this step 3. That says what?
U.
Solve for x in terms of u. So do I have an equation that I could use to solve for x?
U equals X equals
This guy right here, right? What is x gonna be? U minus 3. How can I replace it? You're eating? See, this is from Monday.
Yeah. Hey, come on.
Why did we need to solve for X?
What? Why do we need to solve for X?
Because the actual doesn't answer up the problem.
Are we okay?
Easy.
Did you catch that? Alright, so now let's replace everything, because now we can replace this guy
Good job, man.
with all this, right? So let's do it. So we're gonna have the integral u minus 3, right? Times u to the half times du. Is everything in terms of u now? Yay! Okay? But it's still kind of not what I want it to be. So what could I do with that u to the half? Distribute it, right?
Destroy it.
Not destroy it. Let's give it to everybody,
Oh,
like candy. So u to the half times u, u to the 3 over 2, minus 3u to the half. We still haven't integrated, we're just rewriting the problem so I can integrate. And now it's a simple problem, a little polynomial.
Oh, you won, yeah.
What do we get?
Yes.
You add the exponent.
U to the
Yeah.
5 over 2 times 2 over 5 minus 3u to the 3 over 2 times 2 over 3, the 3's will go away, plus what? Manale,
I'm sorry, I get behind.
Yeah,
plus
I'm
c.
writing it down.
it's 4X.
So can we replace the u already? 2 times x plus 3 to the 5 over 2 divided by 5
Yeah.
minus 2 parentheses x plus 3 to the 3 over 2.
Oh yeah, because.
Oh, we have to put it in.
Fun? Huh? Me like it.
Me don't like it.
No, you don't like these?
No.
These are fun, guys.
I'd rather sit to them.
Now I kind of separated into boxes to help you out, but on your paper you don't have boxes, right? So you just go with the flow, and it hopefully won't take that much space.
Like 6 of them.
Look at the next one. What is u gonna be?
Oh, you're gonna do you added 1.
X
which is
minus
5 over
2.
2, and then you divide it by
What's
5.
du gonna be? 1 dx, or just dx. So we replace this, and we replace this, but did that x squared go away? No, it's not gonna go away, because there's nothing here that's gonna make it go away, right? So it'll be the integral of x squared, u to the 10th, du, we gotta get rid of that x squared. So we gotta use this guy to solve for x, to replace it. So what is x gonna be? U plus 2. Now we can replace him, right, with all of this. Ready? Let's do it. The integral of u plus 2 squared times u to the 10th. It's still a problem, so we gotta expand it, but hopefully expanding a binomial is not as difficult as squaring a binomial is not as difficult as raising something to the 15th power, right? Okay. 2.
Alright, perfect.
Usually by this period, I'm already trembling.
What? Mr. Bolton today, my class?
For what? On Facebook?
Mr. Bolton, it took like 3 fucking weeks.
Yeah, this
today.
Instagram?
Yeah.
What is it called? What is it called?
That little GP.
Wait, really? How do you know?
That little. He said to your parents, like, I forgot that said.
Alright, so how do I square a binomial quickly?
And like, idiot.
Little Gino.
U squared plus 4u plus 4, S mas, right? All of that times u to the 10th du and the integral. We still haven't integrated yet, we're just rewriting the problem.
Oh yeah. He's like Luigi.
Now distribute this guy.
U to the 12
That's wild backwards.
U to the 12, okay?
plus 4U to
Plus
the
4u
11
to the 11,
plus
plus
4U to the 10.
4u to the 10th.
Inflation.
Du, still haven't integrated. Now we're ready to integrate.
U to the 13 over 13
U to the 13th over 13
plus
plus
1 over 3 U to the 12.
4u to the 12th over 12, for those of you that can't reduce it at the same time. Plus 4u to the 11th over 11
Plus
plus c. Thank you.
Power to power is at.
Power to a power, you multiply the powers.
Okay, so should there be
But we're not doing a power to a power, we're multiplying.
multiplying?
When you multiply, you add the exponent. Good? Alright, so let's replace the u and reduce whatever we need to reduce as we go. So what was u? X minus 2 to the 13 over 13 plus 1 over 3 times x minus 2 to the what? 12? Plus 4 times x minus 2 to the 11 over 11.
would they ever tell us like to expand it? Expand.
No, that would be crazy.
It's like you must expand to pass the test.
Good? Got 2 more examples and then that's it. If you want them.
Yes, we do, sir.
Yeah, give me.
You want them? Alright. Let's look at 7.
I like your shirt.
Touch on a shirt, bro.
Sorry, bro.
Yeah, we have like 2, 2, 3.
So we got the integral of tangent squared times secant squared. What do you want to make u here? X. If I make x u, is that really going to change anything? I'm going to get tangent squared u, secant squared u, du. So that didn't really change anything, didn't really cancel anything, didn't really make it look different other than changing the x's to u's and the dx to d's.
Alright, so see here we have Mr.
You want secant
Thinking.
squared?
We're wondering what he's gonna do next.
I mean, don't they have the same variable? Might try to be you.
I'm putting on my faith.
What are we going to do to u after we find it? Take the
Even
derivative.
the part of the card.
We know the derivative of secant squared?
Let us put my faith in the card.
Even the part of the cards.
So maybe that wouldn't be a good one to make you.
Yeah, we need that.
Tangent? Can we take the derivative of tangent? What's the derivative of tangent? Secant squared? So do you think that that's gonna like make something cancel out?
Hopefully.
No.
It's tangent squared, right? Oh man. So would that be the same thing as this,
Yeah,
like
right.
tangent?
Tangent times tangent.
Squared? So can I make this guy be u and then we'll be okay?
Whoa.
Yeah? Let's give it a try, let's see if it works, who knows? If it doesn't work, we'll just do it again. So let's say u is tangent x, so we're replacing that, but we also need to replace this guy. And hope that somewhere along the way, this guy goes away. Right? So what's my du gonna be? What's the derivative of tangent?
Secant squared.
No way. Secant squared x
And you divide.
dx. Divide by the secant squared. So 1 over secant squared x du is equal to dx. Ooh, cool. So was there a need for changing variables? This step 3 in this particular problem?
No.
Or is everything gonna go away? Everything's gonna go away. Okay, so we don't really need this step on this problem. So we're gonna have u squared times secant squared x, right? Times 1 over secant squared x du. So is that secant squared gonna go away? Yay!
So it's just.
Look at how easy of a problem it became in comparison to what it looked like at the beginning. Yeah? Add 1. 1/3 u to the third.
It's about d squared. Can we
Plus
put
what?
tangent? And there's tangent, right?
What do we replace
C
u
squared.
with?
We changed it to this.
Tangent. So 1/3 tangent x to the third plus c. Cool? Easy? One more?
Yes, sir.
Alright, let's give this last one here a try. Oh my god, this one has fractions. Are you serious? What's wrong with you, Mr. Science?
Brother, no.
Why do you do that to us? You're so mean. Can we rewrite those so they're not fractions? Yes, they would be negative exponents, right? So rewrite them. Don't panic. Think of me during the test. I'm like an angel on your shoulder, okay? I'm not gonna let anything happen to you. So what would this become? 1 plus what?
Grab the knife.
After -1.
X to the -1 to the third power times what? Dx. So what do you want to pick to be u?
Wanted to be.
1 plus x to the -1? Alright, good choice. Why'd you pick that? More when we get the derivative, you're gonna get x to the -2 in there? Ah, I like the way you're thinking now. Okay, so what's the derivative of this guy? Because we're gonna replace him, but we also need to replace this guy. And hopefully this guy goes away in the process. If it doesn't, then I gotta do this step 3. What's my du? Derivative of 1? 0. Derivative of this guy? -1x, take away 1,
Yes.
to the -2
How do you say it like that?
dx. And again, technically the dx shouldn't be there, it's on the other side, but you always multiply by the dx so it goes on. Just saving that step, do we understand? Divide by all that, so we get 1 over -x to the -2 du is equal to dx. So does it look like that x to the -2 is gonna go away
Yeah, we're just being.
when I replace this?
Yes. Negative.
Awesome. So do we need to do step 3 on this one? No. So We got the integral from nothing to nothing, just kidding. U to the what? Third, x to the negative 2 times 1 over negative x to the negative 2 du. Does that part go away? The negative is still there, so I'm gonna throw him outside. Negative u to the third. My God, look at how easy it became. All that hardcore stuff right there became this.
Math is easy.
Okay, so let's do it. Negative
That's a joke.
1/4, right? U to the 4th plus c? Oh, that was so easy. What's u?
1 plus x.
1 plus, I'm gonna just put it as 1 over x, but it's the same thing. To the 4th plus c. More than likely, that's how they would write the answer choice, not the one with the negative in the power. Cool? Finally some fun stuff?
Wait, so what are we?
Yeah?
We skip this one?
We have a couple of problems for homework,
Already at
and you also have a free response question like the one we did yesterday, or the one we went over right now before the class started, regarding the second fundamental theorem of calculus, so you can practice that, okay? That's it for today.
Yeah, so you don't have to start to, yeah, okay, I get you. Yeah, okay, yeah.